In the vastness of the Milky Way, Earth is a miracle, and the solar eclipse is a miracle within that miracle. Imagine the sun, a blazing star 1.4 million kilometers in diameter. It is 400 times larger than our moon. By all logic, the moon should be nothing more than a speck of dust against its fire. Yet the universe plays a mathematical game. The sun is also exactly 400 times further away from Earth than the moon is. This perfect ratio ensures that from our perspective, these two celestial bodies appear identical in size. This astronomical coincidence is virtually unique among the planets in our solar system. When the moon glides between the sun and Earth, a dark shadow begins to race across our planet's surface at thousands of miles per hour. This is more than a simple blockage. It is a syzygy, a perfect alignment spanning millions of miles. Over the next 10 minutes, we will explore not just the interplay of light and shadow, but the deep science that has advanced human civilization, proven the laws of physics, and changed our understanding of space-time. From the mechanics of orbits to the hidden mysteries of the solar corona, prepare to enter the shadow. If the moon orbits the Earth every 27 days, why don't we see an eclipse every month? The answer lies in the hidden dimensions of space. The moon's orbit isn't flat against the Earth's path around the sun. It is tilted at an angle of about 5 degrees. Think of two overlapping hula hoops that are slightly askew. Only at the 2 points where these orbits intersect, points astronomers call nodes, does the shadow have a chance to hit the target. Most months, the new moon's shadow passes harmlessly above or below the Earth, lost in the deep void of space. Only when the sun, moon, and Earth align perfectly on this nodal axis does the eclipse window open. Even then, Earth is a vast sphere, and the shadow's path is unpredictable. It might fall over the desolate Antarctic or the middle of the Pacific. On average, a total solar eclipse is visible from any single spot on Earth, only once every 375 years. This scarcity gives the event a near-religious sense of gravity. Call this the cosmic clockwork. Precise, cold, yet hauntingly beautiful. Once you understand the geometry, you realize why ancient cultures viewed this not as a coincidence, but as a divine omen. The shadow cast by the moon is not a solid block of darkness. It is a complex, layered structure. The darkest central core is called the Umbra. If you stand within this cone, the sun is completely obscured, and you experience totality the moment day turns into night. The path of the Umbra is narrow, usually only 100 to 200 kilometers wide, known as the path of totality. Surrounding the Umbra is the Penumbra, a much larger area of partial shadow. Here, observers see a partial eclipse, where the sun looks like a crescent or a bitten cookie. The Penumbra can span thousands of kilometers, crossing entire continents. However, the transition between these two zones is where the magic happens. As totality approaches, the colors of the world turn eerie. Shadows become unnaturally sharp. The light loses its warmth, taking on a high contrast, cinematic quality. This happens because the light source is shrinking from a disk to a thin sliver. You may feel a sudden eclipse wind, a breeze created by the rapid drop in temperature as the sunlight vanishes. It is a full sensory takeover, making everyone in the path feel the immense pressure of the cosmic order. The most spectacular moments of an eclipse occur in the final seconds, before and after totality. Just as the moon is about to cover the sun, a string of brilliant, glistening points of light appears around the moon's dark edge. These are Baily's beads. They are the final rays of sunlight peeking through the rugged valleys and craters on the lunar surface. Each bead is a map of the moon's topography written in light. Then, as the beads vanish and only one brilliant spark remains, the diamond ring effect appears. This is widely considered the most beautiful sight in nature. As the diamond fades, totality begins, and for a few precious minutes, you can safely remove your solar glasses. Round the black disk of the moon, you will see a ghostly, silken halo of white light, the solar corona. This is the sun's outer atmosphere, heated to millions of degrees, far hotter than the sun's surface itself. In normal daylight, the sun is too bright for us to see the corona, but in this darkness, it reveals itself like a phantom flower. You might even see red prominences, loops of plasma leaping from the sun est that are large enough to swallow dozens of Earths. In this moment, time feels as though it has stopped. For most of history, the eclipse was a source of terror. Ancient Vikings saw it as wolves devouring the sun. Chinese saw a celestial dragon. But as humanity moved from myth to math, the eclipse became our greatest laboratory. In 1919, Sir Arthur Eddington traveled to the island of Principe to observe a total eclipse. His goal was to test Albert Einstein's radical new theory of general relativity. Einstein predicted that gravity could bend light. By photographing stars near the eclipsed sun, Eddington proved that the sun's mass actually warped the space around it, shifting the apparent position of the stars. It was the moment that changed physics forever. Beyond relativity, eclipses allow us to study the solar wind and its impact on our technology. The sun's corona, visible only during these rare moments, holds the secrets to how solar storms are born storms that can knock out power. Grids and satellites on Earth. We have transitioned from fearing the shadow to using the shadow to illuminate the deepest laws of the universe. Every eclipse is a bridge between our ancient past and our scientific future. While humans look up in awe, the rest of the biological world reacts with profound confusion. As the moon's shadow sweeps across the land, the rapid drop in light and temperature triggers ancient survival instincts in animals. Bees, reliant on the sun for navigation, suddenly lose their way and fly back to their hives in a frantic rush. Songbirds, thinking evening has arrived, break into their sunset songs before falling into an eerie, midday silence in the wild. The transition is even more dramatic. Nocturnal hunters, like owls and bats, may emerge from their dens, to twit by the false twilight, only to be confused when the sun reappears minutes later. At zoos, researchers have observed giraffes beginning to gallop in anxiety, and hippopotamuses retreating into the water for the night. It is a massive planet-wide biological experiment. Even plants are affected. Some flowers begin to close their petals, and the rate of photosynthesis drops sharply. For these creatures, the sun is the ultimate clock hand. When that clock stops, the world feels broken. Observing these reactions reminds us that we are part of a delicate, light-driven ecosystem. We aren't just watching a rock move in front of a star. We are witnessing the temporary suspension of the natural order on Earth. Capturing a solar eclipse is one of the ultimate challenges in photography. It requires a balance of high-tech gear and precise timing. First and foremost is safety. You must use a certified solar filter, often called a solar cap, which blocks 99.999% of the sun's light. Without it, the sun will melt your camera's sensor and permanently damage your eyes. To get the best shots, you will want a telephoto lens of at least 400 millimeters to make the sun appear large in the frame. As the eclipse progresses, your settings must change. During the partial phases, you keep your filter on and use a fast shutter speed to capture the sharp crescent sun. But the moment totality hits the diamond ring, you must strip the filter off. This is the only time you can photograph the faint, wispy corona. You should use bracketing, taking multiple shots at different exposures to capture both the bright inner corona and the dim outer streamers. It's a high-pressure race against the clock. You have only a few minutes to get the shot before the sun returns. But the result, a high-definition image of the solar atmosphere, is a trophy that lasts a lifetime. For the eclipse chasers, the perfect photo isn't just about the image. It's about freezing a moment of cosmic perfection that the human eye can barely process in real time. There's a unique group of people known as Umbrophiles, literally, lovers of the shadow. These are the eclipse chasers. They don't just watch an eclipse when it comes to them, they hunt it across the globe. From the frozen wastes of Antarctica to the remote islands of the Pacific, they spend thousands of dollars and hundreds of hours planning for a glimpse of totality. For them, 3 minutes of darkness is worth a 30-hour flight. This community is a blend of world-class scientists and passionate amateurs. Scientists use high-altitude planes to chase the shadow, extending totality by flying at the speed of the moon's Umbra to study the sun's magnetic fields. Amateurs bring eclipse festivals to small towns, turning a quiet village into a global hub of astronomy for a single day. There is a profound sense of unity in the shadow. In that moment of darkness, borders, languages, and politics disappear. Everyone is looking at the same sky, feeling the same chill, and gasping at the same corona. It is perhaps the only time the entire world feels like a single crew on a spaceship called Earth. The eclipse chaser knows a secret. Once you see totality with your own eyes, you are never the same. You spend the rest of your life looking for the next chance to stand in the shadow of the moon. As perfect as the solar eclipse is today, it is a temporary luxury in the history of our planet. The moon is not in a stable orbit. It is slowly drifting away from Earth at a rate of about 3.8 centimeters per year, roughly the speed at which your fingernails grow. Millions of years ago, the moon was much closer, appearing massive in the sky and blotting out the sun for hours at a time. But we are moving toward a different future. In about 600 million years, the moon will have drifted so far that its apparent size will be too small to ever fully cover the solar disk. The era of the total solar eclipse will end. Future inhabitants of Earth will only see annular eclipses, the ring of fire, but the silver glory of the corona will be lost to them forever. We are living in a golden window of cosmic history. We are the only beings who will ever witness the perfect match between the sun and the moon. This realization adds a layer of poignancy to every eclipse we see. It is a reminder that the universe is in constant flux. The sky we see today is a fleeting gift, a precise alignment that will eventually fade into the depths of time. We aren't just lucky to be alive, we're lucky to be alive now. The solar eclipse is more than an astronomical event. It is a humbling reminder of our place in the universe, pulls us out of our daily lives, and forces us to look up. To realize that we are passengers on a rocky sphere, spinning through a vast clockwork gallery of wonders. The shadow of the moon reminds us of the fragility of our light and the precision of the laws that govern the stars. Whether you are a scientist measuring the corona or a child looking through a cardboard box, the feeling is the same: awe. As we conclude this journey through the shadow, we invite you to keep that sense of wonder alive. Don't wait 375 years for the eclipse to come to you. Go find it. Seek out the mysteries of the cosmos. If this 30-minute deep dive has moved you or taught you something new, please like this video and subscribe to our channel. Join our community of explorers as we continue to journey through the galaxy. Click the notification bell so you never miss a celestial update. Tell us in the comments, have you ever stood in the path of totality? Where will you be for the next one? Thank you for watching, and as always, keep looking up.